Hello boys and girls, I'm the Guide Knight and welcome to part 4 of my GDScript tutorial basics. We are going to talk in this tutorial about maybe 2 or 3 things, like first it's gonna be operators, then we're gonna talk about statement control flows, and then we're gonna talk, if there is time, about loops or looping. So basically, this is what we're gonna talk about. I figured I would start with operators, even though we should actually continue with this one, because I did not talk about this enough and it's basic topic. I found actually a really nice site called gdscript.com/tutorials, and here you can actually see really nice tutorials, explanation about the GDScript basics. Like you can see like different things about numbers and so on. And we're gonna go about and see what an operator is. Like an operator basically is when you define a variable, it can be, for instance, a number. It can be a string, or it can be an evaluation of an expression. That's called, like this thing on the right side is called an expression, and in that case, this expression evaluates to 124. And this is an operator. There are like several basic operators, like the plus, the division, the times, basically multiplication operator, division operator. There is the remainder operator as well. And also, of course, the minus operator. And here you see that they do have certain precedence. So let's take this example. 2 plus 3 times 2. Maybe you noticed that some of those appear oftentimes in Facebook and they ask, what's the actual result? In that case, it's very easy because there is precedence, right? And the higher the precedence, the earlier it is evaluated. So if I save this and print x, I think it should compile. Let me see if it works. Variable x expected end of statement. What did I do? Plus 3 times of course the times is an x, and I should have replaced it with an actual operator. So what do you think is gonna happen knowing that this has higher precedence than the plus operator? What actually happens is it evaluates it in steps. Like it's evaluated, the higher precedence operators are evaluated first, regardless of where they are. So in that case, this operation 2 plus 3 is lower precedence than this operation. So this operation is going to be evaluated first. So it's going to be 2 plus 6. And this is going to be evaluated to 8. And if I'm correct, I'll now see 8 here in the console. Yeah. So if I wanted to change the precedence, I will just add brackets. In that case, brackets have the highest precedence, and I will evaluate this first, and then I will evaluate this one. So it will change to basically 5 times 2, it's going to be 10, right? Yeah. So this is how you can like work with and without brackets, if you know the precedence. And here, like the highest precedence operator is the negation. So if I have minus plus minus 3 or so, then in that case it will be like -1, and then it will be -2. So, and this is the highest precedence, like the negation. So it's evaluated first. Then all things like division, multiplication, and remainder. What is a remainder? Let me just talk briefly about that. Basically, remainder is if you have like 10, remainder 3. What do you think the outcome will be? Let's see. Why is it going back to the to this stage? Anyhow, it's 1, because this is basically dividing 10 by 3, right? And what is remaining is the remainder. So basically 10 can be divided by 3, and is like equal to 3, something like that. And it 3 full times basically fill in to the 10. So in that case, it's 9, and then the remainder will be 1. So you can say remainder is the highest number, that basically the highest amount of times that your number fits into the other number, and then you basically make a you get this out of the original number. So in that case, it's 10 minus 9. If I had like 5 remainder 2, I will have like 5 minus 4 to be 1, and yeah, basically try to see what is remaining after the whole division. Like if I had like 9, the remainder 3, it will be 0, right? And 11, it will be 2. Like I can check with 2, and then I can check with 0. But it's kind of easy. Probably you already know it. I'm not sure why I waste your time with that. Okay, so the addition and subtraction is clear. Let's go ahead and see some other stuff. Like this is really nice because it's a shorthand writing, right? So basically, all those things are the same. Like if I have a, let me say variable x is 0 or whatnot, and if I had like those two, right? I can comment those. This means that, like, let me start with the long one. Like if I write this, it will mean that I will assign x to the x plus 1. And then you think, okay, what's going on? Like I have x on the left side and x on the right side. That's not a problem because it is actually deterministic operation. Like how it works, it first takes the original value of x. Can I make it bigger? No. It takes the original value of x that it has. In that case, it's 0 on the previous line. And then it evaluates it here, like puts it first on the right side. So in that case, I have it can be any number or any variable on the left side. It first evaluates the expression on the right side, and then it assigns the value to whatever is on the left side. And just so happens it's the same variable. Like if I have variable y equals 0, and I could have the same, it would be exactly the same result, right? But yeah, basically to evaluate 0 plus 1, and then it to assign x to 1. And this is exactly the same. It takes the original value and adds a certain number. It doesn't need to be 1. It can be 5, for instance, to this value. So in that case, if I print x, after each step, I will see that it's iterated by 1, like 1 and 2. And if I change it to, for instance, 5, it will be iterated by 5. Yeah. The same goes for the minus, the times, the division, and the remainder, right? So basically, it is exactly like this thing times 2 is a shorthand writing of this operation, like x is equal to x times 2. It is very useful for looping when you have loops. You want to change some iterative in an iterative way to change some value. I usually write the shorthand because it is much less, well, not much less characters, many less characters, but it's less characters. Yeah, not that many. Okay, so in that case, let's see what this is. It's actually also the same. So if I have like x equal to 10 in that case, and then I have x remainder 3, this will be equal to 1, right? And if I have x remainder 3 as well, it will still be equal to 1 because the highest amount of times 3 fits into 1 is 0. Like it must be on the lower bound. So 0 times 3 is 0, then 1 minus 0 is 1. So I will get 2 ones here. Yeah, if I had like something else, maybe I would get different results. Well, if it's the same, no. I mean on the right side. Anyhow, I don't want to go into too much detail. Yeah, here are Boolean operators. like those are mathematical operators. They're also Boolean operators, and Boolean operators is something that we're going to use right now into in the statements. And there is a bitwise operation. It basically operates on single bits. It can like this thing I almost never use, not only in Godot but also in other languages. It actually very much depends on what sphere you're working on, like what's your main task usually. Well, I'm not gonna go into much detail here, like just those are bitwise operators. This is the negation. It inverts, it's basically on a single bit level, like the bits are zeros and ones, right? And this is 0, this is 1, this is 2, this is 3, 4, 5, 6, and so on. It's like 2 on the to the power of 1 plus 2 to the power of 0, and yeah, 1 times 2 to the power of 1, which is 2, plus 1 times 2 to the power of 0, which is 1, and then you combine them and you get 3. This is how like binary works. And you get like this, the 2 to the power of 1, 2 to the power 2, 2 to the power 3, and so on. It also can be in the other way. In that case, it's little endian, big endian, and so on. You don't really need to know about that, just that you can operate on binary level as well if you wanted to. And like the operators are similar to the logical operators that we're gonna see here. Like for instance, look at this, the logical Boolean operator. And this is like the bitwise operator. It's the same OR operator, but it's a single character. Here is like 2 characters. Or you can just type in OR. Yeah. So let's go ahead and continue with those, right? So let me copy those and see what we can do. I am now going to go back to this. This is the statements and control flows. There are three types of statements and control flows in Godot. One of them is else, if-else. Basically, this is the full expression. And then you have like the, okay, you have also the while and for and whatnot. But there is also the match. Yeah, basically they're like the match, the if-else, and the ternary operator. Like a ternary statement operator, I think, like ternary if-else. Okay, the ternary if-else expression is similar to the if-else, but the while and for are actually loops, so we'll talk about them in a bit. Okay, so the if-else I already showed you. Its statement is like if statement, then something, pass, then else, state. You don't need a statement for else, of course, pass. So here you can put different intermediate steps like if-else and then a statement. In that case, a statement is a Boolean expression that must resolve to true or false. So I will use those comparison operators, or basically those logical operators, to create a statement. And I can use variables or simple or constant, like if I can say, okay, if 3 divided by 3 is equal to, I'm using the comparison operator, equal to 1. Note that the comparison operators are always with an equal on the right side. On the left side is the actual operator you want, except for the greater than or greater or less than. So in that case, you don't need those. So if this is equal to 1, then I'll say print something, like something, literally. And the if, okay, it's, of course, it's not if-else, sorry, it's elif. I am hurrying up a little bit and messing things up. And in the elif, basically it's the same as writing else and then another if, right? But this is a shorthand writing, and you also need an expression here. So I can say this equal to 2, or maybe not equal to 1, then I can say something else. And in the final case, I will get I will fall through when it goes there. So basically, let me just draw a brief explanation, like how it works. Like you have different steps, right? They are different steps inside your execution, and the compiler works from top down, always one line by one, and goes to the next step. Like first it assigns the x, then assigns the y, and so on, then prints, then assigns the x again, then assigns the x, prints the x again, and then it goes to here. And here it can actually branch, right? In those cases, it can branch. Like they are two different cases. Like if it's either true or it's false, like your statement. And if this evaluates to true, it will go here and skip basically the rest. Like if this is written like that, it will not go here, it will not go here. And then it will continue from line 20, right? And if it's false, it will continue with the next branch. It will say, okay, this is evaluated to false, then I will check the next elif, and I'll try to evaluate this as well. And if this is evaluated to true, I will print here, and I'll skip the rest. So this is how it works. I can maybe make it, maybe x equals to 3, and then try to replace it with x to have some suspense. So in that case, yeah, I'll just... Maybe I will even type it, make it typed. Remember how you can make it typed with the colon. Yeah, if I start now, it's basically something. Something 3, something else, not 3. Yeah, so it is because 3 divided by 3 is equal to 1, right? If I change it to 4, then it will still print 3. Why is that? And the reason for that is because this is an integer division. An integer division is basically a whole number division, and it always rounds to the lower part, as far as I know. So like 5 divided by 3 is actually 1 point something, right? But it's still printing that it is equal to 1. If you want to not have integer division, you must, or you can, change one of the numbers to a floating point. So in that case, I'm changing x to a floating point variable, and then it will not be actually equal to 1. It will be 1 something. And I can also like print the actual value, right? I can maybe print it below to see. Actually, I only need to print this. So it's 1666667. It's rounded up as well. It's actually not this not entirely the correct number, but whatever. So it's 166 in period, I guess. And this is how if and else works, right? You put a statement and then you use one of those comparison operators. You can use like greater than 1 or like less than 1. And in that case, I can see GT1 less than 1, and then I can print here, I guess 1, right? Equal 1. So if I start it, it will see, okay, this is greater than 1. 166 is greater than 1. If I make it less than 1, I say, let's say 2. Then it will be less than 1. And if it's exactly 1, it will be equal to 1. Basically, it will be not greater, it will not be less than, so it falls into the else category. Like this is not evaluating to true, this is not evaluating to true, and this is evaluating then to... It doesn't actually need to evaluate to anything, because if it falls through all the branches, the else branch is always executed. And the reason those are called branches is because basically it can look like a tree, right? It does not have loops, it always goes down, and then it continues and merges into some other point, right? It can continue. So in fact, basically it is, if it's true, if it's false, then they're like more. This is actually more like it actually is than what I just drew, but you can write them in a flat way like this. So you can also combine statements with the and or. If like x is greater than 1 and x is positive, is greater than 0. Okay, it's less than 5. I can say okay, but less than 5. In that case, I can simply remove the division to make things clearer for you and for me. So if I say x is 3, in that case to be greater than 1 and less than 5, those for the and, like both must be true. Like this expression must be true and this expression must be true. If both are true, then this will occur. If I have one of them, like, okay, but less than 5, if I have one of them being true, like greater than 1, but this is failing, right? This is 6 is greater than 5, so this will evaluate to false. In that case, I will have 1 or true and false, and this will evaluate to false. Like, in that case, in that case, it goes to the next branch is also false, and then it goes to the else branch, which is always true if you go there. So you can combine multiple of those, or x equal to 2 or so on. So in those cases, basically in the OR case, you need this to be true or this to be true. So if I can say like s equal to 7, in that case, if I have 7 here, okay, sorry about that. If I have 7 here, then it will still evaluate to true, because like this whole branch evaluates to false, and then this branch evaluates to true, but I need one of the two sides. Like this is the one side and this is the other side. I need one of the two sides to be equal to true or 1, because true evaluates to 1 in the numerical sense. And that's why I actually go here, because the OR statement is kicking in. You can replace the OR statements with this. Like this is exactly the same as it was before. I actually prefer writing them out, but some other language use those kind of a nomenclature or writing way. So you can also negate stuff. Like this is a negation, like this is the negation of the equality, so this like not equal. But if I want to negate the whole thing, I will put it in brackets and then I will negate the whole thing. So this means that this must be 7, and then it's true, but I negate it, so in any number that's not 7, it's true. So basically I can have whatever, like minus whatever. In that case, this will be evaluated to false, because minus this number is definitely not equal to 7, but then I will negate it, so I will reverse it. Like in the case that this is false, I will reverse it and it will become true, because the negation of false is true, negation of true is false. So in that case, sometimes the negation is very useful. Those are basically basic logical like operations. I highly advise you to look at De Morgan rules. Let's see, De Morgan laws. Basically, they are very, very useful for dealing with logical operations. Like you can transform them. Like for instance, the negation of two operations, like P or Q, like this is the sign for or, is equal to negation of P and negation of Q. And it may look complex basically, but it's actually very, very simple and super useful. So if you have some time, look into the Morgan laws. They are very useful in that regard. So I guess we are already at 24-25 minutes. I'm not sure how I always manage to take more time than I intend to, but I hopefully come across clear and you get some understanding of that. If not, just don't hesitate to ask me questions in the comments. So I guess, guys, we will not go to the loops today. Surprise, surprise. I wonder if you were thinking, he's not gonna go to the loops. In the beginning, I honestly was thinking that maybe time won't be enough. And it's not enough, so stay safe, stay cool, stay awesome as I know you are, and see you guys next time. Bye bye.